Interfaces and components are probably Embedder's most ubiquitous and perhaps most useful extension, and we use it all the time. It's a relatively sophisticated thing, and so I'm just going to give you a brief overview. So let's look at the tutorial's components implementation module. And what you can see here is that, first of all, you can define interfaces. This is a client-server interface which defines a bunch of operations. In this case, it's one operation. And operations can optionally have pre- and post-conditions. So this one expresses that when called, the P must not be null, the ID must not be 0, the timestamp must not be 0, and then we have a post condition which guarantees that if all the preconditions are met, the results ID is also not 0. We can scroll a little bit further down where we have another interface with several operations and also a few more pre- and post conditions. Notice that you can mark operations as query, in which case you can use them within a post condition and within a precondition, like this is empty, calls this thing. You can also access the result in case the thing is not a void operation, then result represents the result of the operation. You can use result only in post conditions. Once you have interfaces, you can then define components which have ports. And a port essentially refers to an interface and it has a name. And then a component has runables, which are essentially methods, and these can optionally they can be triggered by various things. This is also an extensible mechanism, right? You can say on init, then it's essentially a constructor. You can trigger it by receiving an operation call using a timer, not implemented yet, but will follow soon. And you can also create your own triggers. For example, we've had one system where we had component methods being triggered by interrupts directly. Now, let's first of all, to better understand what we have done here, let's look at the visualization. We can look at the component visualization, which let's zoom in here a little bit and make it a bit bigger, which essentially specifies the available interfaces, and then it says that which component provides an interface and which component requires an interface. We've only seen the providing part so far. Let's look at the requiring side. An interface requirement, the required part, is essentially like dependency injection. So this interpolator it says that it provides the track point processor interface, and that it requires an instance of a component to be connected that provides the track point store. And then from within a runnable, you can then use this port and you can call operations on the port as defined in the interface that's behind the port. You can mark ports as optional, and that's interesting because if it's optional, the port has to be, you have to first query whether the port is actually connected for any given instance. But you can do this by using the when port connected statement. So you would put this thing like this, and then if you move in this check, the error goes away. So in other words, this block is only executed if the port store is actually connected. Let's undo this so that the test still runs. Let's make this non-optional again. You can also mark ports to have multiple connections, but you should look at the user guide to learn the details about that. So once you have defined, and your interfaces can also have protocols. Protocols are essentially state machines that specify the valid sequencing of calls. For example, the store thing can be called initially, and then you go into the full state, and then get can only be called when you're in full, and it stays in full. And if you call take, then you can only call it while you're in full and you're back in empty, and so on. So you can define the valid sequencing of operations in the interface. Now, once you have defined components, you can of course instantiate them. So you can add one of these instance configurations where you can say that you have an instance of this component with that name, and you can make the nuller's processor port available in the C world outside of components under the name n. In which case you can then use the variable n to access this component's instance processor port in order to interact with it. Of course, you can also connect components. Here you have the interpolator component, which wants a reference to a store, right? That's this required port. And so we do that by establishing a connection to the store's store port. Component instances can be parameterized. The way this is done is that they have an init field. Components can have fields which represent the component state, and you can mark them as init. So I guess you get the idea. There is also special support for calling non-public operations or runables from within test cases. This solves the problem that you don't have to make things publicly accessible through a port just to be able to test it. So here we call the process a process runnable directly on this instance using this dollar notation without exposing it. Now, one thing we also support is verification of the ports. You can either do that at runtime. If you do it at runtime, then you get an error message on the console. It uses the reporting mechanism, so it can be redirected to other error memories. Or you can verify it statically. So this in-memory storage component is marked as verifiable. And if I run the verify component action, then it takes a little while, but it runs the CBMC model checker, C-level model checker, to verify that for all executions or for all possible executions of the program, the pre-postconditions and the protocols are always met. And if that's not the case, you get a counterexample which shows you an exemplary program execution that leads to a violation of that contract or pre or post condition. Now again, it takes a while because I have the screen recorder running in parallel. If you do it without the stupid screen recorder, it's quite a bit faster. So I guess we have to wait for a second or two. So this was the checking of the contracts, and now it checks the protocols, and yeah, it's a little bit faster, but we still have to wait for a while. Sorry for that. And yes, I could cut it out, but we decided not to edit these videos. It's enough work to create them all, so we don't do anything here in terms of editing. Anyway, now we see that all post conditions, all preconditions have been met. If I remove this, right? Actually, no. If I remove this one, which is the assignment of the parameter to the stored variable, then the post condition, which says that it cannot be empty after it's executed, would be violated, and it would show it here. And I'm not going to do it because it would take another 2 minutes, but I guess you get the point. So far we have seen components, only regular implementations of components. Let's actually press F12. This gives you the outline view, and there should be a storage mock, which is a component that you can use in a way for testing components. This component provides the trackpoint store interface, but it doesn't actually really implement its operations. Instead, it describes what kind of behavior this mock expects to see in a particular test case. This is essentially mock objects. And here is a little internal DSL, if you will, for specifying that behavior. Like you first expect you expect 5 calls in total. The first one being a call to is empty, which case you return true. The second one, you expect store, and you expect the TP is not null. You also store TP in this variable here, so you can return it later, and so on. So this is a very nice high-level way of describing how a component is expected to behave inside a mock. And then you can have an instance of that guy. Here we have the storage mock instance, and you can run it inside a test case, and then you can call validate mock, which verifies that the mock instance actually did see its expected behavior on its provided port, and if it didn't, the test fails. So that's a good way of kind of testing something from the inside by having mock objects. Mock objects are a well-known concept. We just implemented them for components as well. So far, all our components have been used with client-server interfaces, which are essentially method or operation calls. We also have sender-receiver interfaces, where you specify in an interface, sender receiver interface, SR interface, you specify a bunch of data items, and then if you have a component here, the GPS, which provides that guy, it can simply assign to these variables. And if you have somebody who requires this interface, like this flight recorder, then you can read from these things. So this is essentially data oriented communication, messaging kind of stuff, quite widespread in embedded systems. Of course, our standard transformation to plain C code isn't very impressive for data for sender-receiver interfaces, but of course you can plug in different generators and then, for example, map that onto a CAN bus or onto AutoSAR middleware, which is why we built this, and so then it becomes much more interesting. A final remark: when you look at the build configuration, which specifies how your system is going to be translated, it specifies, among other things, that there is a configuration for components, and it specifies as the generation strategy no middleware. This is where you would plug in other generators, if you had them, for your own particular middleware. And in case of the no middleware configuration, you can specify whether the system should be wired statically or dynamically. If it's not wired statically, like here, then you can use polymorphism behind interfaces. You can have different implementations for the same interface. There is a little bit of runtime overhead because this involves indirection through a function pointer. If you set this to static wiring, then you have to specify, you can only have one instance configuration because you have to know statically how things are wired. And now in this case it probably won't work for all cases, but anyway, in this case there will be no overhead through function pointers, but you also don't have polymorphism. Finally, you can specify whether you want to generate the code that's necessary for checking the contracts statically and dynamically. You probably want to set this to true when you're verifying components, and then when everything is fine, you set this to false, and then in the actual final running system, you don't have the overhead and your code is somewhat more concise and less verbose. Okay, so that's all we had for components. Take a look at the user guide. There are a couple of more quirks and details you probably want to know.